Hello everybody. Based off my last video, many of my students requested that I upload more CAS videos and also cheekily asked if they could see me down sort of in the corner somewhere, I guess, present as I work on the CAS. Unfortunately, I'm not that technologically savvy like the folks at Edrollo. The best I can do is just simply put a photo of myself on CAS. So there I am, but anyway, let's jump into the main purpose of this video, which is all about user-defined functions on the TI Nspire CX CAS calculator. Now, the CAS has many built-in commands available to us, and they can be all accessed via the catalogs, this book button here. So you may have seen fmax, fmin, solve command, the expand command. The CAS has great functionality and can do many things. There are some things, however, the CAS can't do. So what we can actually do is create our own commands, our own custom commands to then save into the CAS, which we can use at any stage. So today we're going to actually see how this is done. We'll make a few, we'll save them, we'll use them, and then we'll see a few other more advanced examples of UDFs. Okay, so just that last paragraph there, just speaking about the fact that they're all customs. So the purpose of UDFs is that you can actually, once you've made this command, it actually saves you keystrokes later down the track. But we'll see it as we make some. So some very common formulas that we end up using over the years: distance formula, the gradient, and straight line between 2 points. If we think about making a command for these equations, the first thing to note is what we would input to the command. So these formulas all involve 2 points, x1 or y1 and x2 or y2. Okay. So when making a UDF, it's really important to think about what the inputs are and what you want your output to look like. Okay. So like when I'm making an UDF, there are 3 things I like to think about. What is it I want my command to do? What do I want to get out of it? What do I want that output to look like? And then when making the actual command, what are the inputs? Okay. So what we'll do is we'll make a command for the distance between 2 points. So what we need to do first of all is imagine we're on the handheld. We'd open up a fresh new document, and this is just a simple calculator page. So to create a UDF, what we should be doing first of all is going to our menu. Now we want to define something, so we're going to go to actions. Now what we're actually going to do here is go down to number 7, library, and we're actually going to go to define libpub. Now see next to libpub in parentheses you have show in catalog. The reason for choosing this particular option rather than the define number 1 up here is because by using the libpub definition, that's going to appear in our catalog, and we'll see more of this later on. We'll go through it now and you'll see the benefits later on. So define libpub. Now this command works just normally like the define command works. So we need the distance between 2 points. We need to call our command something. So let's call it dist. Now when you think about inputs, 2 points, x1, y1, x2, y2. So x1, comma, y1, comma, x2, comma, y2. Now we can just simply from here type in the equation of the distance formula. So square root of x2 minus x1 all squared plus y2 minus y1 all squared. Alrighty, we define that, it's all done. Now, if we want to then have this appear in our catalog, what we need to do is make sure we save this file. So in case you're not quite too familiar with saving files on CAS or opening files on CAS, the file system on CAS is like that of your home computer or your personal laptop. Right? So we want a file, go to File, Save As. Now we've got My Documents. There are a lot of folders here, but we want to save it in the My Lib folder because you want this file in your library. So we'll go down to My Lib, press Enter. Now we need to call our file something. So I'm going to call this file Coord Geometry as a short way of saying coordinate geometry. And we'll revisit this file later on, but for now we'll just save it as Coord Geometry. So we've saved it. At the top there, the file name has changed to what we just called it. And now, if we go to our catalog, to actually access our user-defined function that we just made, we need to go to option number 6 up here, these books. Now, if we scroll down, you probably won't have all these on your screen, but you'd probably see that what you just made isn't there. So before we actually access it, we need to refresh our libraries. So in Document, we've got the option number 6, Refresh Libraries. So press that, and by doing that, it'll now refresh your libraries, and what you've just saved should appear in your library. So by pressing that button again, we see we've got the Coord Geometry option. And if we open that, the dist, that's our command we just made. So if we enter, the thing is now emboldened. So the command is emboldened because it's defined as something. It's defined as this thing up here. Now let's say we want to find the distance between 2 points. So I think I'll go with the classic 1, 2, 3, 4. All right, close bracket, press enter, and there's my distance between the points 1, 2, and 3, 4. Now the great thing about this is if you decide to open up a brand fresh new document, so I'm not going to save that. So here's a fresh new document. I can still use my UDF I just created. Okay, so maybe this time I want to spice it up and go 5, 6, 7, 8. Oh, same thing. Isn't that interesting? Now,